Hello guys, I'm back with another not a lead code problem this time. This time it's going to be a GFG practice problem. So today we're going to do a question on the backtracking concept. So backtracking questions are kind of tricky in the beginning, but as you get a feel of it, you can understand better. So let's start the question now. So here there is a poor rat which is placed at the 0th position, 0 comma 0 in a matrix, and we have to, it's a maze, so 0 is considered as a blockage, or it can't go to that spot. The rat can't go on zeros, it can only go through ones, and there are only four ways in which the rat can go. It can go up, it can go down, or left and right. So these are the various directions in which our rat can travel. So luckily they didn't tell us the rat can move diagonal, then it would be a harder question. So let's try thinking of a recursive approach for this question. So initially the source cell is 0, then the rat can't move anywhere. So in this second test case, imagine this, instead of this 1, imagine there's a 0, then the rat can't move anywhere, we have to return a -1. And here you can see the destination is also 0, the destination is 0, so we can't move, so it's a -1. So first and foremost, before even calling the helper function, we need to make sure that our initial and the final points are 1s, then only the solution is possible, otherwise there's no way we can do it. So we'll try understanding the problem now. Let me open the matrix and let me open the recursion tree. Yeah, so you can see, let's try on this test case first. So let me zoom in. So as you can see the matrix here, so we have to start at 1, and after let's think in a normal way. Let's eyeball the solution now. So we are at position number 0 comma 0. So if you're at position 0 comma 0, then we can't go to the right because it's a 0, and we can't go top because that's the edge, and then we can't go to the left either. So we would go down, and then after we go down, we have how many options do we have? We can't go left, we can't go to the top, we can go down, or we can go to the right. So if we go to the right, we have some options there. If we go down, we have some options. So in such situations, we need to take decisions. So we would understand the recursion tree. So let me go down. Okay, so you're at 0 comma 0. I'll open the matrix side by side so that you people can understand it. Wait a minute. Yeah, so you can see here. Wait a minute. Okay, sorry for this. Just be 0 1. Yeah, so imagine you're at 0 comma 0. We have two options. Up we can't go, so I cancelled it out, and we can go down. We can go to 1 comma 0, and then we can go to the left, and then we can go to the left. We can't go to the left, so I cancelled it out. And right we can't go because 0 is present, as you can see here. The recursion tree is kind of shabbily drawn by me, so just please forgive me for that. So after going down, wait a minute. Let me, sorry about that. Okay, so once we are at 1 comma 0, we have four options. Luckily here three options got eliminated, so we have 1 comma 0 here. We have four options after that. See here, after we are at 1 comma 0, so we have four options. We can go to the right and bottom only. So you can see up is not possible. This position we're talking about, up is not possible, left is not possible, so only right and bottom are possible. If at all we go down, we can go to 2 comma 0, and then we can go to 1 comma 1. So these two positions they're talking about. So let's go left side now. I'll go and explain from the left. So after going to 2 comma 0, what all options do we have? We can either go to the right, 2 comma 0, we can either go to the right, or we can't go to the left, we can't go to the bottom, we can't go to the top. I forgot to tell one important thing. Once we come down, we can't go back up. So because we already visited the node, we already visited the element of the matrix, so we wouldn't go on the top. So we need one more matrix to keep a track of that. So that's why I created one matrix called visited, so that you can check mark, you can keep a track of where what all elements you visited till now and what all you need to visit yet. So we are at 2 comma 1, and then the only option we have is we can go to 3 comma not 3 comma 1, after 2 comma 1, wait a minute. So from 2 comma 0 we can go to 2 comma 1. Yeah, so from 2 comma 0 we can go to the right and go to 2 comma 1. That is the only way we have. And after going to 2 comma 1 we have two options. We can go to the top, we can go up from here, we can go to 1 comma 1, or we can go to 3 comma 1. So why would we go to 1 comma 1? That would, see, if we go to 1 comma 1 also, there's no point of doing it. It'll again come back. So it'll again go back to visited, and the recursion tree, like the branch goes on and it just cancels out there. There's no point of writing it here. There's no place, so I didn't write it here. So after going to 3 comma 1, we have after going to 3 comma 1 we have only one option, which is going to the right. So we go on to the right and we go to 3 comma 3. There is one way. So here our branches got splitted. So I'll explain back from 1 comma 1 here. So here at 1 comma 1 you can see we have gone like this way. So we have visited this node, and now this node, and then same way we follow our path to the end. So this is the way we can do it. So this is the whole recursion tree, you can see. So we end up at 3 comma 3 position. So let's try let's try writing code for this question. I'll zoom in a better way now. Yeah, I think it's all right now. Yeah, so initially what do we need? We need a matrix. We need a matrix called the visited matrix. It's going to be of the size n, because it's going to be same size as the maze to keep track. So we need to initialize the values to 0. Now after initializing these values to 0, so the function wants the function here wants us to return the answer in array list manner. So you can see here it's going to be array list. So we'll create an array list here. So we have created an array list here, and our next step will be to we need all this. So I told about one base condition. If the initials, like the initial point and the destination point, if they are zeros, then we can't get an answer. So for that we'll write a condition. If the if the matrix is initial, let's put it as 0, the initial point, if it's equal to 0, then we would just add it to our answer. We would add a -1 to our answer array list. Let me put it in separate place. And then I would return the answer. So that's one way. And then afterwards, let's keep this as it is, and let's write our helper function. Before that, it would be a void function, because we are just adding elements to our array list. So you guys would have seen a similar kind of question pattern in the generate parenthesis question. That I've made a video on that. You guys can check it out. So let's write this. You can see a similar pattern. All recursion questions in which you have to manipulate a string. I mean, you have to create an array list of all the possible answers. This is the common template which is followed. So public static void. So it would be helper function helper function with the array list as an argument. And then we would need a string. And what else do we need? We need the n value, we need the row, we need the column, and then we would need the visited matrix to keep a track. I told you guys what it is. Okay, now let's write our so now we have created our helper function. So let's write what all arguments we need. We would call the helper function if and only if the n-1 value is not equal to 0. If the last element, if the destination element is not equal to 0, that's the only time we would call our helper function. So it would be the and then an empty string would help us, and then the n value, and then rows and columns would be initially 0, and then we would need we created a matrix here, a visited matrix. So visited matrix, yeah, I think only these arguments are needed, and then afterwards I would return the answer here. So far it's good. Now let's write the base condition. What would our base condition be? When would we end our recursion? So we would end it when we reach the last element. So if the row is equal to 1, I meant not 1, if it's equal to n-1, and if the column value is equal to n-1, if both reach the end, then we would add our answer. We would add a string to our answer, and then we would return back the answer. And then now let's write our recursion calls. So as you can see, just wait a minute, it got messed up. It's getting messed up. Okay, so as you can see, each time we are having 4 recursion calls, right? Up, down, left, and right. So we'll write all of them. We'll write conditions for all of them. So okay, then first we'll write first I'll just create 4 segments in this: down, up, left, right. So first let's write a condition for our down. So when would we go down? We would go down when our okay, I'll do one thing. Let's start from up. And up. So let's write our up condition now. So when would we go up? Up, that's the thing. So imagine, okay, I'll keep it open here. So when would we go up? If the column, if the row is less than 0, if the row value is equal to 0, then we wouldn't go up, right? Or when would we go left? If the row value is if the column value is equal to 0, then we can't go left. And then when we can't go down when the row value is equal to the n-1 value. And when can't we go right? We can't go right when the column value is equal to the n-1 value. So here 4 things we need to write, and then we have to even update our visited matrix so that we can keep a track whether an element is visited or no. Based on that we would do it. So let me write an if condition for that. If the row value of the row -1, so this is for going up, right? So if row -1 is greater than or equal to 0, if it's greater than or equal to 0, then we can do it. And then one more condition: if the visited if the matrix is already visited, let's do the row comma column, row minus 1 is not visited, so it should be equal to 0. And last condition is the one in which if the upcoming position is not equal to 0, then only we can go. Okay, so what is the matrix? Have I passed the matrix as an argument? I think I haven't. Let's check it out. Oh, I didn't pass the matrix as an argument itself. Okay, let's change our values now. So I forgot the main thing. happens. So n and then m values. So it's good to the matrix value. Yeah, so the matrix is there. I would pass the m value here, no problem in that. Yeah, so here if the matrix value of the row which we are going to visit and column remains same, here when you're going up the column remains constant, going up and down the column remains constant. If it's equal to 1, that's the only time we are going to do. And let me update the visited row and column as checked. It should be, because we have visited, no, we have gone from this position to another position, so I'll update it to 1. And now let's do the recursion call here. So you guys need to know one thing. The recursion call, each recursion call you make in your function, inside your function, that is nothing but one branch of the recursion tree. So if you see four branches were coming up from one node, so these are the 4 calls which you are going to make here. If you understand that, then recursion is pretty easy. So let's do the answer, and then we would add it to our inner string that we are going to go down. So we are going up, right? So u is going to get added here. And what else we need? We need the matrix. And then we would need the row is going to get -1 here. And then the column remains same. And the visited, yeah. Is this correct? Let's compare. Okay, matrix. Who is this web developer of GFG? Okay, row -1 column and visited. Okay, there's no problem now. Now we have to even uncheck the value, like, because we are backtracking here, we'll again unvisit, like we'll make it as 0 again. So the remaining function calls are almost similar, except we need to do some changes in that. So for the left, we are going left, so column is -1. So instead of row -1, I'll make it a column -1. And then the visited column -1 should be equal to 0, and the matrix of column so we are going left, so I'll add a L here, and then the column that's it. And again once more. Now this time we are going down. This time we are going down, so I would do some changes here. Row is going to get +1 here. We have to make sure that row +1 is lesser than or equal to the n-1 value. So I'll just do the lesser than n value. And then the visited of the row +1, wherever we are going to visit, it should be 0, and then the row +1 and the column should be 1. Then yeah, here we're going down, so I'd add a D here, and then I'll do +1 and then visited. Yeah, it's good. Here let me do the right, for going right, let me write the function. So here you can see column is we have to make sure it's less than n again. Similar things, column plus 1 here, again column plus 1. Here we're going right, so I would put an R here, and then the matrix row column plus 1, and then that's it. Let me zoom out. Okay, here you can see it's a pretty big. Here I'll tell about the time complexity of this code. So here each time we are having 4 options, so it's going to be a 4 into m into n. For traversing through the whole this thing, we need m rows and n columns are there, so m into n, that's the number of that's the time complexity for traversing through the whole matrix, and then into 4, because each time we have 4 options, either to go up, left, down and right. So yeah, let's check. Column minus 1 is left, and then row minus 1 is going up. Okay, it's good. Let's try running it. Hope we get the right answer. Let me zoom out properly. Okay, so let me compile and run here. So here we have some errors, beautiful ones. Answer.add. Let me refresh the page. The zooming up stuff is messed up kind of. Okay, it's still the same. No, can't do anything. Let me submit once. What errors are coming? So unclosed character literal. So there's an error here. Okay, we'll return it here, no problem. So let me try submitting again. Okay, the variable visited has a problem. Okay, here there's a problem in this. Let's check it out. Okay, there's a spelling mistake here. Visited. Okay, I hope it's good now. Let me submit once more. Okay, I'll do one thing, guys. I'll copy paste this whole. I'll take this whole code, which I wrote here. Yeah, this whole thing, and I'll refresh the. I'll again refresh the page. It's all messed up. The whole zoom thing is messed up. Yeah, now it became normal. So now we can see properly. Let's compile and run. Let's see what's the problem here. Okay, so visited. I have done a lot of mistakes, spelling mistakes here and there. Okay, visited. Okay, visited. Oh, spelling mistakes, man. Visited. These kind of mistakes can put us back in some situations if it's an interview. Here also. Sorry guys can skip a bit forward till I correct all the spellings. Let's see if our arguments are right or wrong. So I haven't, end and m is fine. Let's see where's the mistake. Okay, the arguments are right or wrong. So answer plus inner plus u, and then matrix. Okay, I haven't passed the n value here. Wow. To pass in the n value. Uh, let's compile and run. Yeah, see, we got the right answer. Voila. So let's try for that second. I've told a case, right, wherein imagine the destination and both are like one of them is zero, both are zero. Then we'll try once and check. We should get a -1. Yeah, let's submit our code. Yeah, I've already submitted it once. Yeah, fine. I hope you guys got the point. I'll explain the code nicely once more so that you guys can understand. So here you guys can see, wait a minute. This GFG, man. What kind of interface? So so here we have created a visited matrix and we have initialized all the values to 0, and then afterwards we have created an answer array list such that we can add it to our we can return it as an answer in our function. And then we would only, if the index, if the origin is 0, then we would obviously not get a path, there's no way, so we return a -1. And then if the last number, if the destination is not 0, then only we would call the helper function, our recursive function. And then the arguments are the array list, or the array list of strings, and the empty string, and the n value, which is size of the matrix, and then the m value, m, which is the matrix itself, and 0 and 0 is the rows and the columns which are initially 0, and then a visited matrix. And then these 4 recursion calls, up, left, down, right, you can check the conditions where all we need to do. And the time complexity is going to be 4 into m into n, and the space complexity is m into n. So yeah, hope you guys understood it. Thanks a lot, and please subscribe.